Alright, so we're going to prove another isosceles triangle, and just kind of at a glance, look at how nice and short this little proof is. Isn't that lovely? Alright, so starting with our given, angle M is congruent to angle N. So in our picture over here, we can go ahead and show that congruency. Angle M is congruent to angle N. Now, one thing to kind of notice about this picture is there's only one triangle. So we're not going to have to prove two congruent triangles and then use our CP/CTC. So that's a big reason why this is a shorter proof than some of the ones we've done before. Alright, so we have a pair of congruent angles and we want to prove that triangle AMN is an isosceles triangle. So going to our statements, here's angle M is congruent to angle N, and that's given to us. Now, we just learned this, if you have base angles that are congruent, that tells you that the opposite legs will also be congruent. So that's what we can say next. We can say that side MA is congruent to side NA. Now that came from the base angle theorem, so you just want to make sure you keep these straight. One of them is the base angle theorem and one of them is the converse of the base angle theorem. What we're doing is we are able to say that we have two congruent sides, not congruent angles. So if you're given the angles and you're able to say that the sides or the legs are congruent, that one is the converse. So we're going to say converse of base angle theorem. Alright, well, right there is enough information to say that we have an isosceles triangle. We've got the two legs of the triangle that are congruent. So triangle AMN is an isosceles triangle. And how do we know? Because that is the definition of isosceles triangle. And there's a nice quick little proof.